Hello everyone and a warm welcome to today's video where we are going through the subject of communications and more specifically the relevant weather information. So whether you want to know how to decipher METAR or ATIS or you're preparing for comms or even MET, I'm sure this will be an interesting and helpful quick session. So let's just go into the question and into a bit more details. I'll try to provide you with some more explanations as well. For question number 1, when the term scattered is used in aviation routine weather report, METAR, what is the amount of cloud covering the sky? So of course this is quite straightforward. We have these four names for the amount of clouds covering the sky, which are divided into octas. This is a little bit like a pizza that has 8 slices depending how many clouds there are. This is equivalent of a slice. So of course 1 to 2 is few, 3 to 4 is scattered, and then 5 to 7 is broken, and then 8, so full sky, is overcast. So the entire sky is overcast, the least is few. So of course in this case scattered will be half or less of the sky, which is 3 or 4 octas. And remember, just as a quick a question and a bonus information for you, which is very likely to be asked by instructors during your flight phase, which is what is the difference between cloud ceiling and cloud base. So remember that cloud base, we always refer to the sky or the clouds which are which are few or scattered, and anything above that we have the cloud ceiling. So cloud base is few or scattered, and the ceiling is cloud overcast or broken. And now for question number 2, what is normally used for the ATIS broadcast? So the ATIS is something that you'll listen to a lot in the future once you start flying. This is your go-to information that is coded by a letter of the alphabet and gives you the weather at the appropriate aerodrome station. You can access it on a free VHF frequency, so you will use your normal radio that you have in your aircraft. Some newer aircraft can also access it via data link, so without the voice. However, the most common and most standard is to use a VHF radio. You tune a frequency for the ATIS and listen to the report. In the past, there were a lot of broadcast VORs that used to not only provide radios, however, they also were able to send out this information on a dedicated VHF frequency, because of course VORs, which is VHF omnidirectional range, uses the VHF frequency. So of course it will be either a discrete VHF frequency or something called a broadcast VOR, which is a type of VOR able to transmit on the VHF frequency the ATIS information. However, very often this will be a dedicated frequency on which the airport provides routine ATIS reports. For question number 3, the aerodrome weather report includes data on the cloud amount and cloud base. For example, broken 4000. The reference for the vertical data is, and this question is very often overthinked by a lot of students. However, the answer is the one that makes the most sense. Because of course, if you are listening to an ATIS or in general weather report, you want to know what is happening at that airport. If you are listening to a report in, let's say, Heathrow, London, and you hear clouds 4000, immediately it is very easy to assume, and correctly so, that this 4000 is the altitude or the height of the clouds above the aerodrome, above the station that is making the report. And this is absolutely true. Other ones would make too much confusion on the frequency, and they would not even be that clear. Moreover, the VGS 84 altitude, this is a GPS altitude. This is an ellipsoid that is used by GPS to map the earth and the position of the aircraft. So this would even more so not make much sense, as this is a simplification of the earth's shape in order for us to safely navigate using GPS. So remember that all weather reports will be referenced to your aerodrome elevation, so that you know where the weather actually is above the place that is making the actual report. Sometimes it's good to think about the extremes. For example, if you have an airport at 5,000 feet, sea level, then if you would have a report of broken 4000, this would mean the clouds are below the level of the ground, which doesn't make sense. So sometimes it's good to think about the extreme cases to make the correct answers even easier to find. For question number 4, an aircraft on an oceanic routing without data link wants to obtain information about weather conditions at the destination and alternate airports. How can the crew obtain this information? So you probably might have heard in the past that ATIS and generally speaking the VHF comms do not work over oceanic routes and over far distances. If you have already studied radio navigation, then you probably will remember that VHF, depending on the weather conditions, will have a range of approximately 150 to 200 miles nautical miles, sometimes 300, but in very, very specific conditions. The standard, I would say, is 150 to 200. So, of course, the VHF is only used in short-term comms. If you are going into long-range communications, mainly over oceanic airspace, the main way to do this is HF. The quality of HF will be much worse than VHF. However, it has a greatly increased range and allows for very far communications. This is why you will use HF communications not only for VOLMET and weather, however, you also use it to communicate with some oceanic control centers. So of course VOLMET, which will transmit METARs, VOLMETs are not the same as ATIS because VOLMETs will actually transmit METARs. So VOLMET has basically around 20 to 30 different aerodromes looped all around. So if you miss one airport, you basically have to wait for 30 new METARs to be read in order to come back to the other one. It's a loop of METAR reports and TAFs sometimes that can be either on the VHF frequency, which is less common, and on HF frequency, which is much more common. For the other answers, D-ATIS is your digital ATIS. This is what is required if you have a data link. It's required to have a data link to have D-ATIS. Without data link, you will not have D-ATIS, as the digital ATIS is provided only by certain aerodromes that have the data link connectivity, as well as your aircraft needs the data link connectivity. And lastly, requesting from ATC via voice. First of all, this would be called a weather report, not necessarily an ATIS. However, remember that ATC communicates on VHF frequency for the most part, and this will not necessarily be the most efficient and correct way of using the HF frequencies, which are much more complicated and difficult to use. So remember that VOLMETs, and also here it's good to remember that VOLMET is the only exception from the rule that what is written is true, what is spoken is magnetic regarding the wind, meaning what is written is true. METAR gives you true wind direction and ATIS gives you magnetic wind direction. However, VOLMET, because it reads a METAR, it is the only exception. It also gives you true wind directions. Question number 5. Which option is correct as regarding the following D-ATIS? For these questions, you can of course read everything all at once. However, what I always recommend is to go through the most important information that sticks out in order to find the biggest issues. So for example, here you can see that we have the aerodrome code departure ATIS Foxtrot issued at a certain time based on this METAR. You expect the operational information, so which runway, which approach, sometimes even the arrival. And of course here the arrival is on runway 02 left and departure is on the runway 02 center. So of course if you read the ATIS message, Foxtrot is current, the temperature is 26, then temperature is 27, dew point is 26, we can already exclude this answer. The ATIS is for an aerodrome with ICAO code, Whiskey Sierra Sierra Sierra, taxiway Echo southbound is closed. And then we have taxiing guidance lights on all taxiways are on for lightning inspection. Junction of taxiway Echo Papa and Alpha 3 include rapid exit taxiway Echo 3. So this is not closed. The junction essentially between taxiway Echo Papa and Alpha 3 include a rapid taxiway Echo 3 southbound. It is actually closed. So taxiway Echo 3 southbound is closed due to work in progress. That is also correct. And clouds reported are few, 1,600, and we have visibility 10 kilometers, and clouds are few, 1,600. So far, this makes a lot of sense. And then the ATIS is for departing and arriving traffic. So this is a departure ATIS. For arriving, we can see is a different ATIS Echo. So this is a departing ATIS because that's what it says at the top. And lastly, runway 02 left is in use for departures, and runway 02 Charlie or center is used for departures. So actually, the answer Bravo is the one that makes the most sense, as you can quickly decipher this here from this message. And now for question number 6, a pilot has just noted that the last ATIS for the destination aerodrome on the 20th day of the month. So we have the following. Düsseldorf information, Bravo, MET report at 1020, expect ILS approach runway news 23 left and 23 right. New procedures for localizer critical areas apply. Expect short time ILS interference. Transition level 60. Wind 360 degrees. 4 knots. Visibility 10 kilometers. Present weather light rain. Clouds few. And actually here we can stop for a second because you see the visibility 10 kilometers. And the visibility in a METAR message is always given after the wind. And you can see here that, for example, the second one has 1000. And in every METAR, if the visibility is 10 kilometers or more, it will be written as 999. This doesn't mean 9,999 meters of visibility. This means 10 kilometers or more. So of course, in a METAR message as well, you will never have a transition level. Transition level is something either given by the ATC or provided in an ATIS. So we can immediately exclude the last one because it also has the T060, which doesn't really make much sense. This is not something that you'll see ever in a METAR. Now, if you go forward, you can see that we are left with both of these METARs. The only difference between them, the Alpha and Charlie, is the rain information or decreasing rain. So now looking back on this information, present weather, light rain, light or decreasing rain has a minus, increasing or strong rain will have a plus. This is how you can easily, quickly jump back of the question and the answers. And for the last question of this set of 7 questions, when the term CAVOK is used in aviation, routine weather report, what are the values of visibility and cloud? So CAVOK is the definition. What is the definition of CAVOK? This is a question that is very often asked during either your skill test or by instructors in aviation, so it's good to remember. And this question can pop up in MET, in COMS, as well as in airlaw and flight planning. So it's great to remember. What is CAVOK? CAVOK means that the visibility is 10 kilometers or more. There are no clouds below 5,000 feet or the MSA, whichever is higher. So it's very important to remember this last bit, as many people often forget. 10 kilometers or more, no clouds below 5,000 feet or the MSA with whichever is higher, and no significant weather, including cumulonimbus or towering cumulonimbus clouds. So even if you had cumulonimbus or towering cumulonimbus above 5,000 or the MSA, it could not be considered a CAVOK because you cannot have such. So of course the visibility is 10 kilometers or more and no clouds below 5,000 feet. This will be the definition of the CAVOK. Thank you so much for watching. I hope this was helpful. As always, if you have any questions, feel free to ask them in the comments below. We'll do our best to answer. And until next time, I wish you all the best and I hope you pass your exams with flying colors. Download the Airhead app to never miss a beat. And until next time, bye bye. I hope to see you in the next video.